Section 3.6, we're going to talk about perpendicular lines theorems. And so here's a quick warm-up review of some things that we're going to be talking about and that we will need. So go ahead, pause the video, try these two problems, and see if you get the correct answers. So the answer to the first one, the distance between those 2 points using the distance formula, is 5 units. And if you didn't get that correct, you can check back to the notes where I will work it out, and so you can see and find your mistakes. For question number 2, the correct answer should be 90 degrees for angle ABD. Okay, so again, that is simply because the other angle is DBC is also 90 degrees, so because they form a linear pair, that has to be true. So we are going to use perpendicular lines theorems to solve problems. So let's talk about these theorems, and let's put these down in our notes with some sort of pieces to add. So just as a reminder, the definition of perpendicular lines, we've talked about this before, is that perpendicular lines intersect to form a right angle. That means that angle is 90 degrees right here. That's by definition. Okay, so the first theorem says, if two lines intersect to form a linear pair of two congruent angles, then the lines are perpendicular. So we can see that these angles right here intersect to form a linear pair, and they are actually congruent angles. So we need to mark them that way. So it says if two angles intersect to form a linear pair and two congruent angles, then these lines are perpendicular. So what that would mean then is that if the measure of angle 1 right here, so that's angle 1, and the measure of angle 2 are congruent, and we have a linear pair, then we know that line G, we'll call this G, and line H are perpendicular. So now we can say that this is perpendicular. The second one says if two lines are perpendicular, then they intersect to form 4 right angles. So if A is perpendicular to B, that's what we can see right here, then what we have is that angle 1 is a right angle, and angle 2 is a right angle because a linear pair. Angle 3 would have to be a right angle for vertical angles, and again, vertical angles or linear pair make angle 4. So you have 4 right angles that come from that. Okay, these are kind of obvious theorems, but they have been proven, so let's keep going. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So what we have here is this is two sides right here of two adjacent acute angles. So this is one adjacent acute angle, like angle 1 right here, and then we have angle 2 right here. So if two sides of two adjacent acute angles are perpendicular, so you can see that these are perpendicular right here, then the angles are complementary. Well, that again makes sense because the two angles add up to 90 degrees, so they have to be complementary. So again, these are kind of obvious, but we'll keep going. So the next one is if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So we can see here that H right here is parallel to K. Actually, I did not mark that, so let's go ahead and mark that. So we can see that if H is parallel to K, and this transversal J right here is perpendicular to H, then J will also be perpendicular to K, because those are parallel lines, and these two angles right here are called corresponding, and when you have parallel lines, corresponding angles will be congruent, so that's why J will be perpendicular to K as well. Lines perpendicular to a transversal theorem says if two lines are perpendicular to the same line, then they are parallel to each other. So our two lines that we have here is we have M and N, and we can see here that P is perpendicular to M, and it is perpendicular to P. So because of that, again, this is the converse of the corresponding angles theorem, says if you can show that corresponding angles are congruent, then we know the lines are parallel. All right, so let's try a quick example here. And it says, determine which lines, if any, must be parallel in the diagram. Explain your reasoning. Well, I can see that we have these two angles right here are corresponding angles. So what that's telling me is that these two lines right here, this line and this line, have to be parallel because their corresponding angles are congruent. So that tells you that line S will be parallel to line T by the corresponding angles converse. Now, if you look at these two, so now if we look at this angle, we can see that they are both perpendicular to the same line right here. So they're both perpendicular to this same line right here. So that means that then P will be parallel to Q, and that is by the theorem that we just learned that said if two, we'll go back and talk about it here, if two lines are perpendicular to the same line, then the lines are parallel. So that's what we have here. We have two lines perpendicular to the same line, so that is the lines perpendicular to a transversal theorem. Lines perpendicular to a transversal theorem. Now again, I'm not going to ask you to memorize these theorems verbatim, but you just need to know what the theorems are and why they work. All right, it says find the distance between the parallel lines. So first of all, it says railroads. The section of broad gauge railroad track at the right are drawn on a graph where units are measured in inches. What is the width of the track? So what you're trying to find is that green segment right there. Well, first of all, we can look at line. We need to find the length of that perpendicular segment, but we need to verify that it's perpendicular to both those lines. So what we can do is we can find the slope of QR. So QR are these 2 points right here. So here's Q and R. So we're going to find the slope of that. And what we can do then is, again, use our y2 minus y1 over x2 minus x1. So we can take 55 minus 34 over 91 minus 71, which gives us a slope of 20 over 21. So now we know the slope of this line right here. So now we need to verify the slope of the green segment, PQ, So here's P and Q, and make sure they're perpendicular. So the slope of PQ, again, y2 minus y1 over x2 minus x1, so you have 74 minus 34 over 29 minus 71, which gives us negative, or it gives us 20 here over negative 21. So these are opposite reciprocals. So opposite reciprocals. So we have verified that QR is perpendicular to PQ. And we need that information in order to find the distance between the 2 points, because the distance between the 2 points always has to be that perpendicular segment. So now we can just use points P and Q to find the length of the segment. So to find PQ, remember capital P, capital Q means the length of the segment or the distance between the points. So using the distance formula and those points, we're going to take the difference in the x's. So 29 minus 71 plus the difference in the y values, which 74 minus 34. We square both, add them together, and then we have to take the square root of all of that, which gives us 58 inches. Okay, so now we're going to go on to a skill that's a little bit more challenging, but we're going to do our best to kind of go through this with you. We can review here to find a line perpendicular to line M through this point. This is something that you did in a previous lesson. So let's see if you can remember how to do this. Find a line perpendicular to line M that goes through the point -8, so 1, 2, 3, 4, 5, 6, 7, 8, -8, 2. So you want to find a line that's perpendicular that goes through that point. That's what you want to do, okay? You want to find the equation of that line, okay? So why don't you go ahead and give that a try and see if you can get the correct equation, and then restart the video to see if you got it correct. So the line that is perpendicular to M and through that point 8 or -8, 2 should be the equation y equals -1/3 x minus 2/3. Now, if you did not get that correct, go back to the notes and I will work out this problem in the notes. But we're going to go on and use that information to see if we can find the distance between a point and a line. So it's kind of what we did on the last example, and now what we would be doing here is we would be finding the distance between this point and the line. And remember, that has to be the perpendicular distance, so that's why we need that equation of the line. And oftentimes what we need to do here is now we need to find out what is that point. Then we can use those 2 points and easily find the distance, but the problem is getting that point. So let's look at how we can do that. To find the distance between a point and a line, first you're going to find the equation of the line that's perpendicular through the point. So if this is my given line right here, okay, oops, this is my given line. What I need to do is find the equation of the line that's perpendicular to it. So I'm going to find the equation of the line that's perpendicular to that given line, and that goes through a specific point. So it goes through a specific point right here. Now I'm going to find where those 2 lines intersect. So I'm going to find their intersection point by using substitution of system of equations. So I have to find this point right here using a system of equations. And then I can use the distance formula to find then I can use the distance formula to find the distance between the points. Okay? Now, let's try a specific example. Let's work through this together. I know this is challenging, but let's try to work through this together. All right? So, first of all, it says, find the equation of the line perpendicular through the point. Okay? So, here's our given line right here. And we are trying to write the equation of the line that goes through this point A right here. That point is 1, -2. So it's going through that point, and I'm trying to find the equation of the line that's going through that point. Okay? So that's what I'm doing here. So first of all, I need the slope of this given line. So the given line's slope I need. Well, this slope of this line is going down 2 and then right 3. So the slope of this line is -2/3. So the slope of the line of the perpendicular line right here, that slope will be the opposite reciprocal. So now I can take the slope, and I can take the point that I'm given right here to write this equation. So I can take the slope and this point to write an equation. So the equation line perpendicular to that point would be y equals, I know my slope is 3/2x plus b, but I need to find b. I find b by plugging in that x and y value. So now I would take my y value of -2, plug it in with my slope and my x value. So 3/2 times 1 is just 3/2. So now I am going to subtract 3/2 from each side. And when I subtract 3/2, I'm going to get -3.5. So I could use that. I'm going to go ahead and use the decimal. So my b value is equal to -7/2 or -3.5. So now I have my slope and I have my y-intercept of that line. So the equation of this line, equation that's perpendicular to the line, would be y equals 3/2 x minus 3.5. So I'm going to highlight that. So y equals -3/2 x minus 3.5. That's the equation of the line that's perpendicular through that point. All right. So now I need to find this point. The next thing I need to find is this point right here. I need to find the point of intersection. So I'm going to do that by using a system of equations. I'm going to use the equation that I just found. So y equals 3/2 x minus 3.5. And I'm going to use the equation of the given line. So this equation right here of the given line, the slope is 2/3, the y-intercept, the b value, just from the graph, is 3. So the equation of this line right here is y equals -2/3 x plus 3. So y equals -2/3 x plus 3. So when I use substitution, I could use elimination here actually, which would probably be simpler because it could be anyway, but I'm going to go ahead and use substitution because you can see right here that I have y equals and y equals. So I can take what y is equal to right here and plug it in for y. So then I would have 3/2 x minus 3.5 is equal to -2/3 x plus 3. So now I'm going to solve. I'm going to get my x's on the same side. So I'm going to take 3/2, so that's actually, I could put that as 1.5, but I'll just go ahead and leave it as a fraction. So I'm taking 3 divided by 2 in parentheses, and then I'm going to add to it 2/3, and that gives me As a decimal, it gives me 2.16 repeating. As a fraction, it gives me 13/6. So I'm going to add 2/3 x to each side, and that gives me 13/6. So 13/6x, that's not really working out very well to write it there. So 13, I'm going to actually write it below. So we're going to draw an arrow. So we have 13/6x, and then I'm going to do this in the same step. I'm going to add 3.5 to each side, which is going to give me is equal to 36.5. Now I have to divide each side by 13/6. So I'm going to go ahead and take 6.5, and I'm going to divide it by 13/6, and that gives me 14.08. So I can go ahead and use that value, which gives me, I'm just double checking, 3, oh, this is 13/6 minus K3, so adding 13, oh, this is not 13/6, it's 13/2, my bad, and that's where okay, so that makes this a little bit better. And so 6.5 divided by 3/2, or 13/2, gives us 1. So my x value of this ordered pair is 1, which does not make sense for this problem. So maybe I was right that this was 13/6. The algebra gets kind of messy here. Let me just go back and check my work here. So I am taking 3/2. I'm just going to do that part again, just to double check. So 3/2, I may have typed something into my calculator wrong, plus 2/3. Okay, I'm getting the same thing, so 13/6. Looks like it's right. It was right the first time. And now I'm taking and just double checking when I'm adding 3/2 to each side, or 3.5. So that's 6.5. Yep. Okay, so 6.5 divided by 13/6 gives me 3. Wow. Okay. Somehow I must have pushed something incorrect on my calculator. So 3. So this ordered pair, this intersection point, the x value is 3. So now I just need to take this x value of 3 and plug it into one of my two original equations to find the y value. I don't know which equation will be better. I'll just plug it into this one right here. So I would have y equals -2/3 times 3 plus 3, and that gives me a y value of 1. So y equals 1. So now I know that ordered pair is 3, 1. So now I have the two ordered pairs I need to use the distance formula on. So here is one order, oops, that was supposed to be highlight, sorry. So I have this ordered pair right here and this ordered pair right here. So now I can find the distance between those 2 points. And so now it's just plugging and chugging in the distance formula. And if you do that, it ends up to be 3.6 units. So you can go ahead and try that distance formula, I think, on your own. But what you should get when you find this distance right here is you should get the distance between those 2 points is approximately 3.6 units is the distance. Now, if you're like, what? You can go back and I'll show you what you, again, would plug in, okay? And then you can see if you can simplify it. But when you find the distance between those 2 points, you're going to take the difference in the x's, which would be 3 minus 1 squared, plus the difference in the y's, which would be 1 minus a negative 2, which is going to be plus squared. And so that's going to give you the square root of 13, which is approximately 3.6. So this is a pretty involved problem. Now sometimes you can kind of luck out and you can kind of use your slopes to get to another point and not have to do that whole substitution thing. So if we know that, I'll kind of explain that right here. If we know, try to find a different color here. If we know this is the point A, and we also know that the slope is 3 over 2 because it's perpendicular to the other slope, we can actually just go up 3, 1, 2, 3, and over 2, and we could actually get that intersection point that way. And that would have been a lot simpler, but as you know, sometimes those intersection points aren't going to be on nice ordered pairs. All right, the last thing we are going to just quickly bring up is the distance between 2 lines. Now, the difference between this is you don't have a point to start with. So if you look at this, you're trying to find the distance between these 2 points. So you have to choose a point on one of the lines and maybe try to choose one that makes sense, and that would be pretty simple. So now you find the equation of the line through that point, okay? That would be perpendicular, okay, to the other line. Well, these 2 lines have the same slope. So if we just think about this, the slope of this line is going up 2 over 1, so m is 2. And again, the same thing here. We'd go up 2 over 1, so this slope is 2. So we know the perpendicular slope. So this perpendicular slope is going to have to be the opposite reciprocal, and that would be negative 1/2. So you might be able to just apply your slope, okay, and go down 1 over 2 or up 1 over 2 and keep applying your slope, up 1 over 2, up 1 over 2, but now I'm off and that's not going to quite work. So you might have to like try some other strategies. This is pretty involved, okay, but I am going to go through all of these steps on the notes, but I'm not going to take the time to do it here on the video. So go ahead and get to work. This is the end of the 3.6 video, but go ahead and check back to the notes for more information.